We are looking at U.S. population. We are going to go ahead and go through the correct answers for this. This is all about how many people there were at each census. So it's over a 10-year period. So we're going to go through. So we know we've got from 1790 to 1990. And it tells us how many there were total in millions. For example, in 1990, there were 248,709,873. Okay? So we're going to go down to question number 1, which we looked at together. If you want to create a model that would help you predict the population in any given year, what variables would you use and what would they represent in the situation? So we would use X equals years and Y equals the population. We're going to say pop for population. So everybody should have that written down. Okay, let's look at our scatter plot. Okay, so we know along the side we had 1790, 1800, 1810. I am going to go through and list this. Hopefully you already have this written down. 1860, 1870. There shouldn't be any talking right now. You've got other things you can be doing. We go to 1910, 1920, 1930, 40, 50, 60, 70, 80, 90. And we counted up the sides. We counted by 11, a lot of you did. We talked about going up by 11 million. So if these are in millions, we go 11, 22, 33, 44, 55, 66. I'm skipping every other one so you can see it. 77, 88, 99. We go 110 million, 121, 132, 143, 154, 165, 176, 187, 196, 209, 220, 231, 242, 253, and 264. Okay, so then we're doing it in millions. We go back to our first page. And in 1790, I go up 3 million, so it's not a whole lot. I go up 5 million, again, it's below. 7 million, still below. 9 million, still below. Up, I'm up to 12 million, so I'm right above the 11 million mark there. In 1840, I'm up to 17 million, so I'm below the 22 still. I'm at 23 for 1850, so it's right above. I'm at 31 for 1860. For 1870, I'm at 38, so I'm still below this 44 mark, but very close to it. I'm at 50 million for 1880, 62 for 1890, 76. I know this is boring. I understand, but you need to have this down. 92, 106, 123, 132.
This is so boring.
151. Just so you know, you're being recorded right now, and I feel very comfortable sending it to your parents. 179. 203. Took a decent jump here. 226, 248. Okay, so that right there is our scatter plot. Number 3 says, using a red pen, well I used red, so I'm going to use green. Draw a line of best fit. A line of best fit is a line that's closest to as many points as possible. All right, let's see if we can undo that. Okay. All right, let's try that again. As many points as possible. Okay. Then we go to number 3, and it says, find our linear regression. So we have to plug all of that information into our calculator, and we got something to the effect of y equals 1,215,400x minus this huge number, 2,211,000,3,200,000. And this right here is our correlation coefficient. And then we plugged in the following numbers for x to figure out what y is. 219,48. So 219,480,000 for 2000. For 2010, 231,634,000. And then finally for 2020, we would get something super big like this. $243,788,000. Okay. All right, let's move on to 4. 1,215,400x minus 2,211,320,000. But you can look at my answer to be accurate. Okay? All right, I'm going to move on to number 4. Okay, 4 is right here. 4, we found the exponential. So we went back to our scatter plot. And in a different color, let's see if this works, we made a exponential function. Looks something like that. Well, that's closer than our line is, correct? So that's at least a little better. So let's look at our exponential. We got an equation that looked like y equals 0.000, 3 zeros, 3 more zeros, 3 more zeros, 4, 1, 7, 8, 3, 9 times 1.02099 to the x. Remember, exponential equations are raised to the x. So then when we plug in 2,000, can you please sit down and check your answers? You can do that in a minute. We get 461,303,000. When we plug in 210, we get 567,807,000. And then when we plug in 220, we get 698,901,000. Okay, that's for each one of those. And what's the next regression you guys have to find? The what? What's number 5 say? You have to find the?
I got different numbers on that one.
When you plugged it in for x? Well, we can check it. So get out your calculator. Plug in your equation. You find the right number of zeros. That. 3, 2. got 461, 303. It's the exact same number I have.
Oh.
All right, let's look at the quadratic. I'm going to move it up just a little bit so I can fit the quadratic on here. Okay, our quadratic equation, our regression is y equals 6506.31x squared minus 2337.8400x plus 21 billion 6 billion. All right, and when we plug in 2,000, we get 274,440,000, so 274,440,000. When we plug in 210, we get 3,015,590,000. So in 2010, we should have, wow, 3,015,590,000. A lot of people. In 2020, 329. I think I added a 0 for 2010. Anybody get a different answer? I think I added an extra 0. I think it actually should be 3,015,591,2,3. I think it should be this, 301 million. That would make sense because in 2020 we had more people. All right. Next, ladies and gentlemen, which one do you think was the closest to the actual numbers? Do you think it was linear, exponential, or quadratic? So I put down quadratic. And when you look at it, I think it's because it crosses through the most points. If you look at it in your calculator. Okay, so what you had to do for the next part is plug in your numbers, okay, for linear, exponential, and quadratic. So in 1995, we got 213,403,000. For exponential, we got 415. Wow, that's a really big number. 1,794,000. Which one's closest so far, the linear or the exponential, to the actual population? Linear, so let's look at quadratic. 261, oh, that's really close. 368,000. For 2,000, we got 219,480,000. For exponential, we have 461,303,000. For quadratic, we have 274,440,000. For 2005, 225,557,000. For exponential, is that helping that they're different colors? 792,511,792,000. And then we've got 287,836,000.